Hello everyone, and this is Sandeep Swamy. You are watching Samyans Academy, and in this session we are going to discuss about motion around us or describing motion around us. Okay, from 9th class, new NCERT. Okay, before going to this, you have to know the terms position, what is distance, what is displacement, what is the speed and velocity and acceleration, and all these terms are the building blocks of the motion. Now you see, what is motion? So while defining the motion, first you have to know what is the reference point. Reference point means observe. So you are observing me, means you are the reference point. With respect to you, my position is not changing. If position does not change with respect to you and with respect to any object or any reference point, if position is not changing, that means it is said to be at rest. With respect to you, I am moving. You see, I am now moving. So I am moving from one place to another place, right side or left side. So that means you are moving with respect to reference point. I am moving. With respect to the reference point, I am moving. Then it is said to be object is in motion. Right. So while defining the motion, we have to consider the reference point. So reference point means a fixed point used to describe the position of an object. So the reference point is not moving. The reference point is placed at one fixed position. Okay. With that position, we are observing the position of another object. Is it moving or is it rest? So position means you are considering the distance with reference point, how much distance it is there and which direction it is moving. Is it moving left side direction or is it moving right side direction? Okay. And position, well, considering the position, so we have to consider the distance from the reference point and the direction of object from the reference point at a given instant. Okay. Now motion. So already we discussed motion means how do you define this? If your position is changes with the time, it's said to be object is in motion. If position does not change with the time, then it's said to be object is at rest. Okay. Now describing the position of an straight line, just you consider this. Now you see here, describing the position of an object, we have to take one reference point. I am taking a reference point. O is my reference point. Okay. So O is reference point. Now the distance is a 0 meter. Right. So mark the reference point as origin on a number line. So next, if object is moving towards right side direction, suppose this is a car. If this is moving towards the right side direction, then position of the right carries a positive sign. So in this side, you have to take positive sign, plus 20, plus 40, plus 60, plus 80, plus 100, like that. If object is moving with respect to the reference points towards left side direction, so in this case, you have to consider the negative sign. Okay, if object is moving left side to the reference point, you have to take position of an object is negative. If object is moving right side from the reference point, you have to consider the position of the object is positive. Is it clear to you, everyone? Okay, left side of the O is negative, right side of the O is a positive. So direction is essential. Position is not just a number, it is a number with a direction. So position we are mentioning with in which direction it is moving. If object is moving with respect to the reference point towards the right side, you have to consider the positive side. If object is moving with respect to the reference point, if it is moving towards the left side, you have to consider the negative side. Okay. Move on to the next one. Now you see distance versus displacement. Okay, so what do you mean by distance and what do you mean by displacement? So distance always tells the actual path length covered by the object is the distance. So how do you define this? The total path length covered we called as the distance. Okay, then displacement is net change in the position. So initial point and final point. The gap between the initial point and final point gives the displacement. Let us take one example here. So consider one example here. So is it visible to you? Right. So for considering the distance, we should not consider about the direction. Okay, it's a scalar quantity. It depends on only value. That means it depends on only magnitude. The scalar quantity depends on only magnitude. But the displacement depends on vector quantity. Okay, so displacement is a vector quantity. So vector quantity means with the direction, the value of the magnitude will change. Okay, while moving positive direction, you have to consider plus. While coming back again you have to subtract minus 60. 100 minus 60 is 140. Like that. How? Now you see. While considering the distance, you have to consider O to A is 100, A to B is the how much it is? A to B is 100 to 40. This is 20, 60 meters. 60 meters. So, okay, this is 20, this is 20, this is 20. Okay, so O to A is 100 meter. Again, A to B is up to here 60 meter. Okay, so the total distance covered by is 160. Total distance covered by the object is 160 in this way. Sorry. So distance equal to 160 meter, right? So while considering the displacement, if object is moving O to A means positive 100 plus 100 you have to take. From A to B it is moving towards left side direction means towards left side direction. The value you have to take negative. So 100 minus 60. So that gives you displacement. Okay. So displacement is 100 minus 60, which is equal to 40. Okay, your distance is 160 meter and displacement is 40 meter. Is it clear to everyone? Right? Okay. So from this we observe that the distance is always positive. It is a scalar quantity and it cannot be 0. Only if no movement, in that case only you have to consider it is 0. Relationship. Okay. Now you come to here. Displacement. Net change in the position. You have to take starting point and ending point. So while considering this, the starting point is here. The starting point is starting point is O and ending point is B. Okay. The gap between O to B is 40 meter. Okay. So the net change in the position, starting point and ending point. So it is a vector quantity. Okay, depends on direction as well as magnitude. So now it can be 0. Yes, it can be 0. Yes. How it is 0? So when object is moving from O to A, let us take plus 100. Again it come back to the O. Again it is minus 100. So plus 100 minus 100 becomes 0. If initial point of the object and final point of the object both are coinciding or both are matching, in that case the displacement becomes 0. From this if object is moving again it left side direction, in this case also displacement becomes negative. Okay, like that you have to consider displacement. So displacement, it can be 0 or it can be negative or it can be positive. Okay, it can be positive or it can be negative or it can be 0. Okay, so in which case the displacement becomes 0? If initial point and final point both are coinciding, in that case the displacement becomes 0. Okay, so the relationship between the distance and displacement, the magnitude of displacement, it may be equal or it may be less than distance. When it is equal, if object is moving straight line in one direction, in that case the distance and displacement values both are same. For example, so if object is moving from O to B, okay, B to A or A to C, like that. Okay, so 20 meter, 20 meter, 20 meter. So 20 plus 20 plus 20. Total distance moved from O to C is 60. Okay, in this case, so let us say our object is moving from O to C. In this case, the distance is 60 and displacement also 60. Okay, in this case, the displacement value is equal to distance. Okay, for example, if object is coming back to again C to A and again it is A to B, in this case you have to consider minus 20 minus 20, 60 minus 20 minus 20. The 60 minus 40, how much it is? 20 meter. Okay, so distance is 20 plus 20 plus 20 plus 20 plus 20. So total how many 20s? 5 20s. So 5 into 20, 100. Distance is in this case is 100. But displacement you have to consider. So in this case the displacement value is lesser than distance value. Okay, it may be equal or it may be So it may be equal or it may be less than the distance. Okay, displacement value is always, it may be equal to the distance or less than or equal to the distance. But distance you have to consider always positive, and distance is a scalar quantity, displacement is a vector quantity. Okay, is it clear to everyone? Right? So move on to the next one. Now you see distance versus displacement. Work the example we are taking here. So let us say this athlete begins at origin O and runs to A, covers 100 meter in the positive direction. Again returns to B, runs back to the 60 meter to the point B, 40 meter from the O. Just now we have considered the same example we are taking here. Okay, in this case the total distance moved by athlete is 100 meter plus 60 meter. Let us say, now you see, consider if object is moving, okay, if object is moving from O to A. Let us say this is a O point, O to A is a 100 meter. Okay, O to A is a 100 meter. Runs to A, covers 100 meter in the positive direction. If object is moving towards right side direction, means it is positive direction. Runs to B, run back to the 60 meter to the point B. Again, it run back to the point B. Let us say this is run back to 60 meter. Okay, so in this case, what is your distance and what is your displacement? Can you tell? The distance in this case 100 plus 60, which is equal to 160 meter. But displacement is while object is moving towards right side direction, you have to consider here 100 plus 100. If object is returned back in left side direction, so object direction is changing, it is coming towards left side. That means you have to take here minus 60. 100 minus 60 is a 40 meter. So this is the gap between the O to B is a 40 meter. Okay, this is initial point, O is the initial point and B is the final point. Okay, the gap between the initial and final point is how much? That is 40 meter. If you do in this way also, you are getting 40 meter. Okay, so the total distance means you have to consider O to A and A to B. OA plus AB, that is 100 plus 60, 160, and the displacement OB equal to 40 meter in positive direction. So key insight, fuel consumed depends on distance, not displacement. Yes. Okay. So in this way you have to consider distance and displacement. Now, instant of time versus time interval. Let us say a single clock reading at specific point in time, suppose 4 seconds. Time interval means duration between the two instants time you have to take from 4 seconds to 10 seconds. Means at the 4th seconds your object is starts to move. Suppose you are observing, after observing for 4 seconds, the object is about to start. Okay, initially it was 0 seconds, but 0 seconds the object is not moving. Let us say you are observing at this time. So whenever you are observing, that time you consider 0 seconds, but 0 to 4 seconds the object is not moving. Okay, let us say the object starts off its motion from 4th second to continue its position, its movement up to 10 seconds. You have to consider this interval only. Object starts moving at 4th second. Okay, 4 to 10 seconds. During this time only you have to consider. So total how much? 4 seconds to 10 seconds. 10 minus 4 is 6 seconds. You have to consider only 6 seconds. So SI unit of both distance and displacement is meter. Okay, units of distance and units of displacement both are in meter. You have to consider meter. Okay. Now move on to the next average speed. For example, you are moving from one place to another place. Let us say total distance traveled by time interval. So that is what? Average speed. So average speed formula is, what is the formula of the average speed? What is the formula of the average speed? So average speed equal to average speed, we can write like this. So average speed equal to total distance traveled by total time taken. Total distance by total time. Okay. Let us say the gap between Hyderabad to Chennai, let us say around 900 kilometers. Okay, Hyderabad to Chennai is 900 kilometers. We are moving by car. Okay, so to complete this journey, let us say you are taking 10 hours. 10 hours. Okay, from starting from Hyderabad to Chennai, how much you are taking for this journey? How much time you are taking for this journey? 10 hours you are taking. Then in this case, what is your average speed? So average speed, always you consider what is the total gap between the Hyderabad and Chennai, that is 900 kilometers. Approximately I am taking this, and the time taken for journey is 10 hours. 00 cancel. Then your average speed becomes 90 kilometer per hour. So in this way, we have to consider the average speed. So average speed is a scalar quantity. So no need to consider the direction in this case, and the SI unit is meter per second. So the units for distance is meter and the time is second. So meter per second. Average speed. So speed equal to distance by time. Then average speed equal to total distance by total time. Okay. Scalar quantity is a scalar quantity. So while doing this, no need to consider the direction. And uniform motion. So what do you mean by uniform motion? If object covers equal distances in equal interval of time, it is said to be uniform motion. That means the object is moving with constant speed. Suppose you are moving by any vehicle or any bike or car. Suppose your vehicle is showing always constant speed. Suppose your car is moving 60 km per hour for 5 hours, like that. 60 km per hour, 5 hours. It reaches to up to how much distance? 60 into 5, that is 300 kilometers it will reach. Okay. Suppose you are maintaining the same speed. So your speedometer is not deflecting. It is always showing the 60 km per hour. Means you are moving with the constant speed. In this speed, in each hour, your object is moving with, suppose, let us say you are starting from the A to B, B to C, C to D, like that you are moving. So let us say you are taking 3 gaps. So A to B, your car is moving with 60 km in 1 hour, means 60 km per hour. In the next hour also your car is moving 60 km per 1 hour. In the next session also your car is moving 60 km per 1 hour. Okay, if your object covers equal distances in equal intervals of time, it is said to be uniform motion, right? So what do you mean by uniform motion? If object covers equal distances in equal time of interval, it is said to be uniform motion. That means the object is moving with constant speed, right? In every 1 hour, object covers 60 kilometer distance. Means it covers equal distances in equal interval of time. Then it is said to be uniform motion, right? So what do you mean by non-uniform motion? Suppose it is not covering in equal interval of time. It is not moving equal distances. Let us say in first example, it covers 60, 60, 60. For example, you take the next example here. Okay, if object covers A to B, B to C and C to D. In each hour, let us take, in first hour it covers 60 kilometer, and the next hour 40 kilometer, and the next hour let us say 80 kilometer. Okay, if object is not covering equal interval of unequal distances in equal interval of time, or equal distances in unequal interval of time, it is said to be non-uniform. That means you are not moving with constant speed. Your speed is varying, depends upon road conditions or traffic situations. Your speed is varying. In that case, it is not said to be uniform motion. So it is only non-uniform motion. If your speed is varying with respect to time, so that is said to be non-uniform motion. Means in non-uniform motion, object covers unequal distances in equal time of intervals. So its speed is changing. Okay, your speedometer, the speedometer is not showing constant reading. It is always deflecting. That means your speed is changing. Okay, that is said to be non-uniform motion. So next one, average velocity. Now we discussed the average speed. Average speed means average distance by average time, but average velocity. So average velocity means, how do you consider this average velocity? Average velocity means displacement by time. average velocity equal to total displacement. Okay, total, you no need to consider total, so you write displacement by time interval. Okay, whenever you consider the velocity, you have to consider here displacement. So displacement is a vector quantity and velocity also vector quantity. Okay, and these two are the vector quantity, and these two and has both magnitude and direction. Vector quantity has direction as well as magnitude, so it is a vector quantity. While moving right side direction, you have to consider positive sign. While moving left side direction, you have to consider the negative sign in straight line motion. Here we have one example. So this is swimmer example taken from your textbook. Saran swims a 25-meter pool and come back in 50 seconds. Okay, Saran swims how much distance in pool? 25 meter. Okay, Saran swims a 25-meter pool and back in 50 seconds. Okay, the swimmer is moving. Let us say this is what 25-meter distance swimming pool, and one person covers 25 meter. Okay, 25 meter like this. From, let us say this is a point A and this is a point B. Okay, point A to point B, point A to point B, he covers. Let us say this is a point A and this is a point B. So he moved distance up to A to A. Again he come back to the B to A. Okay, in this case, what is your average speed and what is your average velocity? In how many seconds he come back? In 50 seconds he come back to the original position. Let us consider here average speed. Okay, so average speed, how do you consider? Average speed equal to total distance he traveled. Total distance he traveled means the total distance covered by total time taken. Let us consider the total distance covered from A to B is 25 meter. Okay, and B to A also 25 meter. So 25 meter plus 25 meter, the total distance he covered by total time taken for this journey is time taken by swimmer is how many seconds? 50 seconds. So 25 plus 25 is 50. So 50 by 50, how much you will get here? 1 meter per second. Okay, the average speed is 1 meter per second. But in this case, the average velocity, how it becomes 0? Can you tell? Yes. Why? Because he starts from the A and reaches to the B. Again he come back to the A. In this case, the initial point, final point both are coinciding. If initial point, final point, if both are coinciding, in this case, the displacement value becomes 0. If displacement is 0, velocity also 0. Okay, he is moving from A to B 25 meter in the right side direction. Okay, in right side direction he is moving 25 meter. Okay, B to A, again he come back, means in left side direction he is moving. So you have to consider negative sign, 25 minus 25 by total time. Okay, that is 0 by 50. So that is 0. That average velocity is 0 meter per second. Why? Because object again coming back to the position A. Right. In this case, the average velocity is 0. Okay. Now, average acceleration. Acceleration means if your speed keep on increasing, okay, with respect to the time, it is said to be you are accelerating. You are accelerating your vehicle. Okay. And suppose you are driving a scooty in the right side, you have an accelerator. Okay. If you rotate that accelerator, the speed of the vehicle also increases. Means your speed is increases with respect to time, means it is said to be accelerating. Your vehicle is accelerating. So how do you take the acceleration? What do you mean by acceleration? Acceleration equal to change in velocity by time. So acceleration equal to change in velocity v2 minus v1 by t2 minus t1. Okay. Suppose you are moving in car. So your car is speeding up. So whenever you observe the speed of the car, let us say your speed of the car is 30 km per hour at 0 seconds. Okay, at 0 seconds. After few seconds, your speed of the car increases. Within 10 seconds, your speed of the car increases to 100 km per hour. Means your speed is increasing in within 10 seconds. Your speed of the car increases from 30 km per hour to 100 km per hour. So in this case, your car speed is increasing with respect to time. It is said to be acceleration. So acceleration equal to change in velocity by time. Suppose it is in kilometer per hour. So just you convert this into meter per second. Okay. Here time also in seconds. Okay. So this will give you V1 and this is V2 and this is time gap is so starting time is 0 second, ending time is 10 seconds. So T2 minus T1 difference value is 10 seconds. Okay. So this is the formula for calculation of the acceleration. Acceleration equal to change in velocity by time. Okay. So what do you mean by acceleration? So acceleration equal to change in velocity by time. Acceleration equal to change in velocity by time interval. Okay. The units is velocity units is velocity by time, right? So velocity units is meter per second by second. Then acceleration units becomes, so change in velocity indicates with the delta V and change in time delta T. Okay, del means your speed is changing with respect to time. Okay, meter per second by second. So it will become meter per second square. So this is the units for acceleration. So what are the units for acceleration? Meter per second square. While your car speed is increasing, speeding up, acceleration in the same direction. So velocity you have to consider here positive. This is what your car speed is accelerating. Suppose your speed is decreasing with respect to time in opposite direction. Decreasing means you have to consider opposite direction to the velocity. Means your speed is coming down, right? That indicates negative acceleration, and negative acceleration also we called as the retardation. Okay. So this negative acceleration we called as what? A retardation. Positive acceleration again, so you consider acceleration only. For negative acceleration, the negative acceleration also we can consider here retardation. Means your car speed is decreasing with respect to time. So this is what acceleration. Here we have working example. Acceleration worked example, burst speed. Let us say the burst speed is increases from 36 km per hour to 54 km per hour in 10 seconds. In this case, what is your acceleration? Okay, let us say here V1 value is, let us say here V1 value is how much? What is the V1 value? V1 they have taken here 36 km per hour. Okay, how do you change kilometer per hour into meter per second? Already you know that 1 kilometer equal to how many meters? 1 kilometer equal to 1000 meters. 1 hour equal to how many seconds? 3600 seconds. So 0 cancel. Okay, so 2 5 okay, 2 18 times. This is equal to 5 by 18 meter per second. Okay, to change kilometer per hour into meter per second. So just you have to multiply with 5 by 18. Okay, so the 36 into 5 by 18. How much is the 18 one time? 18 to the 36. 2 5 are 10. So V1 you will get here 10 meter per second. V1 is equal to 10 meter per second. The 36 kilometer per hour we can write as 10 meter per second. Okay, then V2. So how do you calculate the V2? So V2 also similar way. So 54 km per hour. So to change this in meter per second, you have to multiply with the 5 by 18. Okay, 18 how many times? 3 times. 18 3 ja 54. 3 5 ja 15. 3 5 ja 15. 15 meter per second. Okay. Okay, the speed of the car, the speed of the bus increases from 36 km per 50 km per hour in just 10 seconds. Okay, so what is the formula for acceleration? Acceleration equal to change in velocity by time interval. Okay, so V2 is how much here? 15. V1 is 10. The time gap is 10. 15 minus 10 is how much? 5 by 10. So 5 by 10 we can write as 0.5 meter per second square. Okay, the acceleration you will get here 0.5 meter per second square. If bus braking means within 5 seconds the speed of the bus decreases to 54 km from 0. sorry, the speed of the bus decreases to 0 from 54 kilometer per hour. So in this case, what is your acceleration? Let us consider if bus braking. In the next situation, what is the V1 you have to consider? V1 is 54. The bus coming to the rest means the speed of the bus decreases to 0, means V2 is 0. Okay, so V1 is here. What is the V1 here? V1 is, so in the next situation, 51 equal to 50, V1 equal to 54 kilometer per hour. So 54 into 5 by 18, how much it is? 18 3 ja, 3 5 ja is 15 meter per second. Okay, so after braking the bus, the final velocity of the bus reduces to 0. In how many seconds? In 5 seconds. The time gap is 5 seconds. So now you consider the acceleration. Acceleration equal to change in velocity by time interval. So change in velocity, V2 is 0, V1 is 15, by time gap is 5. Okay, minus 15 by 5. So this equal to minus 3 meter per second square. So in this case, the acceleration is minus 3 meter per second square, means negative acceleration indicates decreasing in speed. Okay, so the acceleration value is minus 3 meter per second. For falling object, suppose if vertically falling object is falls from the top to bottom. In this case, the acceleration is falls with acceleration 9.8 meter per second square. So in this case, the velocity is increases while falling object. While falling down, the velocity of the object increases, means that is positive acceleration. When it is object is thrown up in vertical direction, the velocity of the object decreases. When it is reaches to the highest point, the velocity becomes 0. That means that is deceleration. Okay. While coming down, it is accelerating. While going up, it is decelerating. That's all. Okay. So move on to the next one. Graphical representation of motion. So this we will consider. This we will discuss in the next session. Okay. Thank you.